Hi, my name is Sham and I'm from BET S21. Hi, my name is Sham. So now I want to explain about the definition of AC induction motor. An induction motor or asynchronous motor is an AC electric motor in which the electric current in the rotor needed to produce torque is obtained by electromagnetic induction from the magnetic field of the stator winding.
Hello, my name is Jensen Marshall, and today I will be explaining about the different types of AC induction motor. Generally, there are two types of AC induction motor, which is single-phase induction motor and also three-phase induction motor. This is a single-phase AC induction motor. The construction consists of the rotating part, the rotor, and also stator winding. That is made up of the main winding and auxiliary winding, which is perpendicular to the main winding while attached to a capacitor. When an AC current is flowing through the main winding, it produces a fluctuating magnetic field. The fluctuating field is equivalent to sum of two oppositely rotating magnetic fields. It is also called the double revolving field theory. The fluctuation induces current into the rotor bars that is surrounded by magnetic field, thus producing force according to Lorentz law. But there are two oppositely rotating magnetic fields, so torque will be both equal and opposite, and rotor will have zero torque and will not start. It will simply buzz. We can overcome this by giving the rotor an initial rotation, so that one torque will be greater than the other, resulting in a net torque in the same direction as initial direction. Thus, the loop will keep rotating in the same direction. This is where the capacitor comes in. There are two opposite magnetic fields in auxiliary winding, also in main winding. One of the magnetic field from auxiliary winding will cancel out the rotating magnetic field from the main winding, while the other one gets added up, resulting in a single magnetic field, which will then give starting torque to the motor. That's it for single phase. For three phase, the only main difference is that the windings is connected to all of the phases instead of just a single phase. When an AC current is flowing through the wire, there is a maximum and minimum peak, maximum being positive and minimum being negative. When DC current flows through wire, it produces an electromagnetic field, but when AC current flows, it produces a fluctuating magnetic field, where the size is at its maximum when near the positive or negative peak. Here we have two coils placed oppositely in the stator. When an AC current is inserted, a pole is produced that flips back and forth as it passes through each cycle of the wavelength. In three-phase, the angles are 120 degrees shifted off each other, so that each of the wire will receive its maximum at different time. What this results in is a rotating magnetic field. The magnetic poles of the rotor is polar opposite to that of the magnetic field. Thus, the poles repel each other. This is what drives the motor to rotate. This concludes the two types of AC induction motor. Thank you.
Is ready? Okay, let's begin. Okay, my name is Narhanis binti Azmi. My part is to explain advantage and disadvantage of AC induction motor compared with synchronous motor. Let's begin our video. Here we begin. Advantage of AC induction motor. The first key point is robust and sturdy. And the second point is the construction of stator is similar in both synchronous motor. Third key point is polluted and explosive. Fourth key point, safe starting torque, unlike synchronous motor. For the last advantage key point is full load efficiency. Disadvantage of AC induction motor. First key point is during three-phase induction motor. The last point or disadvantage is during light load condition.
Hi, I'm Hurin Masturina from 1BEET S1/1. I will explain on the AC induction motor application. I will show you how the induction motor used in the centrifugal pump.
The induction motor. Shaft is run between rotor of the motor are got into the pump. The impeller melted into the shaft. The induction motor rotates the shaft, which in turn rotates the impeller. Changing the speed of the motor will changing the speed of the impeller rotation. Impeller inserted in the pump casing. The pump has two ports that are inlet and outlet. Inlet always at the center of a horizontal axis while the exit is in a vertical axis. The horizontal axis is the suction line while the vertical axis is the discharge line. Pump casing had a volute running around the circumference of the pump casing. The volute sitting outside of the casing has increasing the diameter fluid from the start inside the pump all the way around up until the discharge of the outlet. Changing of diameter allow more water to flow. The water or fluid start enter to the pump through the outlet port. As the water enters into the impeller, the force push it out toward the edge. All the water has pushed against the edge is collecting into the volute. All has collecting are making a way out to the top. Impeller have a vane curve shape. This type of impeller known as a backward curve type of impeller. The vane do not push the water out. The water flow between the vane and the vane provide force that push the water out of the pump. This low pressure suction force the fluid into the center of the impeller. Certain force show that the fluid will exit the impeller. As the water collects in the volute, it slows down. It converts kinetic energy into static pressure. The water continues to flow in behind and push the water in allowing to maintain the pressure. This allows water to be pushed through pipe all around the building. This is the example of the pump building.
Hi, my name is Luman. I will explain to you about this circuit. Itu is counter EMF. Next, the counter EMF for itu is equal to the stator terminal voltage less the voltage drop caused by the stator leaking impedance. So for the formula for itu is equal to V1 minus I1 for the
So now is for the conclusion. This is the conclusion that I can conclude by relating AC induction motor and subject BEE 2373. You guys can see here the conclusion.